Okay, so in this third part of our unit on supply, we're going to be taking a look at costs. So we've looked at revenues, and we've looked at the production function. So the final portion of the unit we're going to deal with is costs. Now, from a firm's perspective, they have several different kinds of costs, things that they have to spend money on. We have four that we're going to really concern ourselves with, although you can see up here kind of a table outlining a whole bunch of different costs. All of the different costs have different abbreviations. You can see here VC, AVC, FC, AFC, TC, MC, ATC. And we could probably observe that, that there's a few of them that kind of seem to align here. You have total, and it goes with VC, and then you have per unit, and that's AVC. You have total, that's an FC, and per unit, AFC. So these two are going to be linked, and these two are going to be linked. We're also going to find that these three are going to be linked together. So the per units MC and ATC are going to link with this one. Now, I'm going to talk through what each one of these different means, but you can see here at the bottom we have some notes about each one of them. So the first one that we're going to take a look at is actually here. We're going to look at marginal cost. This is by far and away the most important one because we remember MR equals MC is the most important point. That's where we profit maximize. So figuring out MC is pretty important. So this is the idea of change in total cost divided by the change in the output. And so we can look at here a few different features, right? We've got change in output 0 to 8, right? From 0 to 8, and the cost goes up 25. So we're gonna need a little calculator in order to do some of these. And the reason that these data points are a little bit difficult is actually because we are using the same data as as we previously used in this unit. So we'll kind of take our little handy pocket calculator out. I don't know if you can see that very well, but we have 25, right? 25 divided by 8, and you get 3.125. So we would say that the marginal cost, not here of the first one, but of this one, is 3.13. 3.13. So we're rounding up, and that's $3.13. $3.13. We're going to repeat that process here, 25 for each of these, but then we're going to divide each time by the change in total product. So we'd say here change in total product is 10, so 25 divided by 10 is 250, and then we have 25 divided by here, the change is 8. 25 divided by 8 again is just $3.13. Then we have 25 again divided by, now here, 6 divided by 6 is $4.17. Then we have 25 divided by 4, that's $6.25. And then we have 25 divided by just 2, right? Divided by 2, and that's $12.50. So we could find that the really marginal costs express kind of, they start a little high, right? They start very high, and then they go down, and then they go back up again. And so they have this J shape, right? So if we were to kind of graph it off to the side, it would do one of these. It would look like a Nike swoosh. It does one of those. So you could imagine that here's like that $3.13, here's that $2.50, and then comes back up to $3.13 and then goes back up again. So it does one of those. This has a J shape because it initially declines due to specialization of labor. And that specialization is happening where the output is rising. With these first two workers, they specialize, and so the marginal cost is actually falling. However, at this point, at that lowest value, $2.50, it's going to start to come back up again because of diminishing marginal returns. So understanding the idea of our production function is really useful to understand the shape here of the marginal cost curve. And one additional thing that I'll point out, the marginal cost curve kind of looks like this, right? And if you remember from a couple of lectures ago, the total, or the marginal product curve actually looks like that. Sorry, I can't really see that. The marginal product curve looks like that. And so they are actually mirror images of each other. So this is like a marginal product, and that's a marginal cost curve. They're mirror images of each other. Now, Our next one that we're going to take a look at is AFC, and this one's over here in the middle. This one's actually pretty straightforward. This is just the total fixed cost divided by the quantity of output. So this is an average, right? It's an average. We're not dealing with marginal here. These are just the average. So you take the fixed cost and you divide it by the amount of output. So again, we're going to hand over to our trusty calculator here, and the fixed cost is going to be 50, so this is our total fixed cost, and it's $50 every time, so 50 divided by, and then at this level, 0, right? Uh-oh, what do we get? That's an undefined value, so you don't have an average there. And then 50 divided by 8, right? So what's the average fixed cost of units at 8? That's $6.25. That's how much we can spread out this fixed cost over those 8 units. Now let's divide it by a total of 18. Now it's $2.78. Right? $2.78. And now divide by 26. It's $1.92. $1.92. It's getting smaller each time. And now let's divide by 32. 156, right? 156, a little bit smaller. And now let's divide by 36, 139, and divide by 38, 132, 132. So what do we notice? We notice that it's a really high value early on, but then that fixed cost gets spread out over more and more units. So we'd say that it has an L shape. If we were to graph it off to the side, we were to graph it, it would do one of these. It would kind of do one of those, right? Because at the early quantities, it's going to be really high, but then it'll kind of flatten out. And as you noticed, it started to get, the amount that it decreased each time get a little smaller and smaller. That's because it's going to flatten out. It's never going to become 0, right? It's never going to reach that 0 value. But it'll become an asymptote to the x-axis. So then we're going to take a look at average variable cost. And before I move on, average fixed cost is actually not super important for us. Not super important, but this one we would say is really important. Marginal cost is really important. Average variable cost. This one is really key to understanding whether a firm should keep operating in the short run despite earning a loss. And we're going to talk more about that in this unit and in the next unit in particular. But the Avc curve is going to be pretty important. And this one is just the variable cost divided by the quantity of the output. So for this one, the numerator, right, the variable cost is going to change. Sorry, I won't pull that down there. The numerator value is going to change, and we're going to change that total quantity of output. So we'll get our trusty calculator out again here, and we'll say, here, for the average for the 0th value doesn't exist, but we have total variable cost of 25 divided by 8, and so we get 313. And then we get 50 divided by 18, and it's 278. So I'm dividing 50 by 18, and then 75 divided by 26 is 288, and 100 divided by 32 is 313, and 125 divided by 36 is 347, and 150 divided by 38 is 394. So now we start to notice something about the AVCs. They start high, 313, then they go down, 278, then they start to tick back upwards again. So unlike AFC, which starts high and just goes always lower, 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 AVC has a U shape. And we'd say that it kind of does one of these, actually. So it's similar to the marginal cost curve, but it is not the same. And just actually easier to draw than drawing the J that we actually have seen up here in the data. You can get away with just drawing AVC like that. That's okay too. But it sometimes is easier to draw it with a little bit of a J shape. When we put them all together down at the bottom, we're going to find that to be true. Now, the key important part, and I'm going to tell you a bullet point next to that, marginal cost always intersects AVC at the AVC's minimum point. So let's importantly note something that happens up here in the data. The minimum point, right, of AVC is actually going to be where the MC curve is going to come through that value. And it's a little bit hard to see with our data set up here, but it's going to occur at that quantity level that we have here of this 18. With this data that we have, it's a little hard to see, but it's going to occur at the quantity of input, since that's actually how we've had these. But when we graph it out, the MC curve is going to come through, so the easier way to say this is come through the AVC, like that, off to the side. So here you have an AVC, and it's going to hit that minimum of the AVC. The AVC's minimum. It's going to have a marginal cost curve, but it's not quite the minimum, coming right through the minimum point. Now, the reason that the AVC curve has that U shape is because initially it's going to go down because of specialization, right? You think what we're really doing is we're spreading out that variable cost over more units of total product. But at a certain point, the specialization is no longer as beneficial, or sorry, is being outweighed by the diminishing marginal returns. And that's because of that fixed units of capital. So the variable cost is going to get higher and higher and higher in an average sense. The last one to know is average total cost, ATC. And this one is key to understanding if a firm is earning a profit or a loss. And we're gonna learn why these things are true later. Marginal cost is going to intersect ATC at the ATC's minimum point as well. So we're going to put a bullet point next to that. We're going to observe the same thing happening up here with ATC. Now this one is calculated as just the total cost divided by the quantity. So all three of the averages are the total of the cost divided by the quantity. Total of the cost divided by the quantity. Total cost divided by the quantity. And with the average of the total cost, it's just the entire total cost divided by the quantity. So let's take a look here up at the top and make sure we can see. For the 0th value, we don't have one, 50, so but here we're going to move on. 75 divided by 8 is 9.38, so $9.38. And then 100 divided by 18 is 556, and then we have 125 divided by 26 is 481, and you have 150 divided by 32, 469, and then let's see here, 175 divided by 36. Ooh, now we're starting to go back up again. 486. So see, we hit a bottom, and now we're coming back up again. And 200 divided by 38 is 526. So we can see with these that they start high, they go down, they hit a bottom point, and then they come back up again. But note that the ATC doesn't bottom out, so we're going to say here is that's the point where they bottom out. It doesn't bottom out at the same point as the AVC. Excuse me. AVC bottoms out here earlier than the ATC, and that's because, excuse me, I had to take a drink there. That's because the spreading effect is going to lower the ATC as the fixed cost is spread out over more quantity. So that ATC is getting lower and lower, and that's pulling down the average here. But eventually, the AVC starts to outweigh it. Right? So we call this the spreading effect because we're spreading out that fixed cost over more quantity. The diminishing returns effect is going to increase the ATC as this value starts to come back up again. So this value is going to start to pull and outweigh the fact that this value is getting smaller and smaller. Now, one interesting fun fact to observe, right? I know you're excited about fun facts. $3.13 plus $6.25 is $9.38. Boom, ATC. So we know fixed cost plus variable cost equals total cost. Well, we also know that average fixed cost plus average variable cost equals average total cost. This is really not that exciting in that you know if you just divide each of these three by the same value, then you get these things. But it is kind of neat to see, yes, that actually holds true. You know, if you added $3.94 to $1.32, it is $5.26. And it has to be, right? It has to be that value. So, and that's because this ends up holding true. Okay, let's finish this lecture up here by graphing all of these together. And I didn't graph this one, but it is just a U shape as well. It's just one of those. It just bottoms out. The minimum point is a little bit later. So we're going to do this. We're going to say, here we have a y-axis and an x-axis, price and quantity. And I'm going to tell you that there's kind of an order to doing these, to making sure these are easy. We're only going to graph the AVC, the MC, and the ATC. We're only going to graph those three things. AFC is nice, but we're not going to really worry about him too much. We know that he just does one of those, and we're going to leave him off to the side. So maybe he's a little lonely over here. So the first one that we're always going to graph, that's always easiest to graph, is marginal cost. So we're going to start here and come down and go straight back up again. And marginal cost is, if you take your fingers and cross that part off, marginal cost is actually a supply curve. It is the firm's supply curve, is an important part to kind of observe here. So before here, right, before that minimum point, everything past that is actually equivalent to the firm's supply curve. So we could actually put equals SF there for firm's supply curve. And then we're going to graph the AVC. And the AVC, we're going to come down, take our pen off, right? So we hit that minimum point. And the easiest way to do it is to take your pen off and make a dot. And then come back up again, right? And that way you get that nice minimum point at where the MC is. If it's not at the minimum, you're getting it wrong. ATC, next. Start a little higher up here, and then we're going to come down, down, boom, hit that minimum, and then we're going to come back up again. ATC. Now, one thing to note is that my lines aren't actually the same distance apart, and that's because ATC and AVC are going to get closer and closer and closer together as the quantity goes out. That's because the distance between here and here is actually the AFC. That's the AFC. That's because, if you think about, remember up here, AFC plus AVC equals ATC. Well, if you have an AVC and then you add to it the AFC, you get the ATC. And the distance between these, right, is the AFC. So why would it be getting smaller and smaller? Well, look up here. AFC, always getting smaller and smaller. Eventually, this number and, this number are going to get closer and closer together. And we notice that they do, as time goes on, they get closer and closer together. That doesn't seem that close, but given enough units, it would eventually get closer and closer. So maybe the technically accurate thing to do would be to draw this one a little bit farther on the left, a little bit closer on this side. So hopefully this helps you in terms of your graphing, and we're gonna be able to know a little bit more about what we're gonna do with these cost curves in a future lesson. I'll see you next time.